Hey, it's Mr. Lineski. It's the last video of Unit 5, our triangles unit. How sad. We have Section 4, CPCTC. What exactly does that stand for? It stands for corresponding parts of congruent triangles are congruent. What exactly is this thing? We will find out. So, as I mentioned, corresponding parts of congruent triangles are congruent. If you think about what those words are saying, it's saying that any parts that are corresponding with each other, meaning that they match, angle A matches with angle E, of congruent triangles, meaning we've marked two triangles congruent, we can then say that the corresponding parts are congruent. One thing I want to point out is that this thing is not ever used to prove two triangles are congruent. This is something that we use after two triangles have been proved congruent. So, what exactly does this do? So, once we prove two triangles congruent, and that's where we're either going to use a side, a side, angle, side, an angle, angle, side, an angle, side, angle, or a hypotenuse, leg. So once one of those things occurs, what can we do? Well, all other parts that are not marked on the triangle, we can then say are congruent. So let's take a look at what exactly this looks like and how we use CPCTC in a proof. So you're going to see some proofs that look probably a little familiar. So in this proof, we're given that QT is congruent to RS. So I'll mark that. We're given that QR is congruent to TS. But look at what we're trying to prove. We're not trying to prove two triangles are congruent. Instead, we're trying to prove that these two angles are congruent, that angle TQR is congruent to angle RST. So we're actually trying to prove that this angle and this angle are congruent. And so I wrote a little hint over here for you that if you're trying to, if your prove statement is something besides two triangles congruent, meaning if it's an angle or a segment are congruent, then we have to use CPCTC. So if you don't see a triangle here, then you're going to use a CPCTC. So let's take a look at what this proof looks like. So we're going to state our givens first. So we have QT congruent to RS. That gets a star. That's a given. We have QR congruent to TS. That gets a star. That's a given. And then remember, we're looking for that third star, third congruency statement. So where do we get that? We get that from our shared side. Boom. So we can say RT is congruent to RT. That's a star. So why do we say that? We say that because of reflexive property. So now, what do I do when I get my three stars marked congruent? Well, now I can prove that the two triangles are congruent. So now you have to say a triangle congruency statement. So I could say something like triangle TQR is congruent to triangle RST. And what did we use to prove that? Well, we had a side, and a side. So we use side congruency. Now normally that's where we would stop in the problem, but now we're going to continue. So what CPCTC does is we say, hey, now that these two triangles are marked congruent, anything that you didn't mark in your figure, now you can mark congruent. Specifically, in this particular problem, we didn't mark any of the angles congruent to each other. So that's where now I can prove this thing. And I can say now, well, angle TQR is congruent to angle RST because of CPCTC. So at the beginning of the notes, I had a picture of a little key in the lock. And that honestly just symbolizes what CPCTC does, is that once you prove the two triangles are congruent, you're sort of now unlocking the rest of the triangle. Everything that you didn't have marked before, now you can mark. And so that's sort of what CPCTC is all about. All right, let's take a look at one last proof. So we've seen this one a couple of times. I is the midpoint of GK and JH, so that's our given. So knowing that I is a midpoint, midpoint cuts the segments in half, so GK gets cut in half. So that means I can say GI is congruent to KI. Why can I say that? Definition of midpoint. Same thing, I is a midpoint of JH, so I can say that JI is congruent to HI. And again, I can say that because of the definition of midpoint. So 1 star, 2 stars, we need to find our third star. And remember, when we have this bow tie or sort of hourglass looking shape, we can always mark our vertical angles. So now we're going to say that angle GIH is congruent to angle JIK. Why is that? That's our vertical angle congruence theorem, or definition vertical angles. And again, take a look at what we're trying to prove. We're trying to prove that GH is congruent to KJ. So now that we have 3 stars, what can we do? We can prove the triangles are congruent. So now I can say triangle GIH is congruent to triangle KIJ. And notice how the letters now match each other. So GI has the 1 tick mark, so if that's what I'm starting with, I want to make sure I start with KI, because that has the 1 tick mark as well, and then go in that respective order. So now I prove these 2 triangles are congruent with what? With side angle side, with some sass. I did it with sass. So now that we have proved the triangles are congruent, I now unlock the rest of the triangle, essentially. So what can I prove now? I can prove that GH is congruent to KJ because of CPCTC. So again, once I've proved the 2 triangles are congruent, I can now say, oh, this would be congruent to this. G and K match up, so I can say this angle would be congruent to this angle. I could say this angle would be congruent to angle J. And you kind of unlock the rest of the problem. So that's what we use CPCTC for. So the rest of this worksheet are just some practice problems. I believe there's 2 proofs on there for you to practice yourself. So thank you for watching.